Okay, here's some writing equations practice. Feel free to fast forward to whatever ones specifically you are looking to practice. My recommendation as you're working through is to pause the video, give the graph in question a go, try to see if you can come up with that equation on your own, and then restart the video when you are either ready to check your answer or to hear an explanation if you got stuck. Okay, so I have prepared here one linear and then two of everything else. Okay, so linear first. Go ahead and pause the video, give it a shot, restart it when you are ready. Okay, so linear. Let's go ahead and start with our form. We have our y minus our y1 equals m times x minus our x1. Okay, my y1 and my x1 can technically speaking be either point. We can use -2, 0 as my hk or 2, 3 as my hk. Okay, so for the sake of example, I'll go ahead and do both. So this first one we're going to do our -2, 0. Our second one we're going to do our 2 and 3. Okay. Now here's where our other point comes in, because since I used -2, 0 here, I'm going to use 2 and 3 to help me find my slope. 3 for my y and 2 for my x, which means 3 equals 4m, and so my slope is 3/4. And so my final equation would be, sorry, I lost my train of thought there for a second. My final equation would be y minus 0, or y, equals 3/4 times x, either minus -2 or plus 2. Okay, over here, if we were to have used the 2, 3 as my initial point, then I'd use -2, 0 as my other coordinate pair to find slope. And so we'd have 0 minus 3 is -3, -2 minus 2 is -4, which means my slope is 3/4, right, which makes sense. That's what I got over here. And so my final equation would be y minus 3 equals 3/4 times the quantity of x minus 2. So we have two potential right answers. Okay? Okay, next up, we're going to do two absolute values. So my recommendation with each one, pause the video, give maybe the first one a shot, restart it to check your answer, hear the explanation, then pause the video again, give the second one a shot, restart it when you're ready to check your answer or to hear the explanation. Okay, so go ahead and pause the video now if you're going to. Okay, absolute value, we have y minus our y1 equals m times the absolute value of x minus my x1. Now with absolute value, it does matter what point we plug in as our hk. This point needs to be 4, 0. I'm sorry, not 4, 0, 4, -1. This y goes down 1. Right, 1, 2, 3, 4, down 1. Okay, and so my h is going to be 4, my k is going to be -1. Here's now where the other point comes in. My other point is 1, 1. So I'm going to go ahead and plug that in. 1 plus 1 equals m times 1 minus 4. 1 plus 1 is 2. The absolute value of 1 minus 4 is 3. And so my slope is 2/3. And so that's my equation. Either y minus -1 or y plus 1 equals 2/3 times the absolute value of x minus 4. Okay, next one. Pause the video if you're going to do so. Okay, we have our y minus our y1 equals m times the absolute value of x minus our x1. My coordinate point is -1, 4. My vertex here, my hk, so we have -1 and 4. Now I'm going to use my other point down here, -2, 0, to solve for my m. So -2 and 0, plugging those in. We have 0 minus 4 is -4, and -2 plus 1 is -1, the absolute value of which is 1. And so my slope is -4. we've got our final equation. So y minus 4 equals negative 4, either absolute value of x minus negative 1 or absolute value of x plus 1. Okay? Next up, we've got some quadratics, 2 of those. So again, go ahead and pause your video, give it a shot, restart it when you're ready. Okay, we have our y minus our y1 equals m times x minus our x1 quantity squared. Our hk does matter to this point here, which is that x equals negative 1, 2, 3, 4, and y equals negative 1, 2, 3, 4, 5. So we are at negative 4, negative 5. Okay, so plugging that in, negative 4 and negative 5. My other point then is going to come in. My other point over here is at negative 1, negative 2. So we have negative 2 plus 5 equals m times the quantity of negative 1 plus 4 squared. Negative 2 plus 5 is 3, and negative 1 plus 4 is 3 squared is 9. And so my slope is 1/3. So we've got our equation, either y minus negative 5 or y plus 5 equals 1/3 times the quantity of x plus 4 squared, or x minus negative 4. I just realized I was calling this slope, but quadratic, technically speaking, is stretch here, right? Because quadratic is not a linear, so it does not technically have slope, just for the record. Okay? Okay, coming down, we've got our y minus our y1 equals m times x minus our x1 quantity squared. My hk, my vertex, is over here at x equals negative 2, y equals 1, 2, 3, 4, 5, 6. And so plugging that in. Then my other point comes in, which is at x equals negative 1, 2, 3, 4, 5, and y of positive 1. Okay, plugging that in then, my y is 1, my x is negative 5, 1 minus 6 is negative 5, negative 5 plus 2 is negative 3 squared is 9, and so my stretch is negative 5/9. So my equation is y minus 6 equals negative 5/9 times the quantity of x either minus negative 2 or plus 2 squared. Okay, and so those are your quadratics. Okay, next up we've got some exponentials, 2 exponentials here. Okay, so same thing, I would recommend pausing the video, giving it a shot on your own, restarting when you're ready. Okay, so my exponential, we have y minus my y1 equals a times b to the x minus my x1. Now remember, with your exponential, my initial point here, my hk, comes from my asymptote. And so I'm actually going to be looking below this coordinate point for my hk on my starting point. That's my hk right there, which is at x equals 2, y equals negative 1, 2, 3, 4. So my hk is actually at 2, negative 4. Okay, and now we're going to have to use both coordinates one at a time to first solve for a and then solve for b. So my first coordinate is at 2, negative 3. Okay, so plugging that in, we have negative 3 plus 4 equals a times b to the 2 minus 2. Negative 3 plus 4 is 1. A times b to the 2 minus 2 is the same thing as b to the 0, which is 1. And so my a is 1 in my equation up here. Let's go ahead and rewrite it with a as 1. So we have y plus 4 equals 1 times b to the x minus 2. And since this is 1 times, I don't actually have to write it. right? Think about what 1 times anything is. I could actually just write this as y plus 4 equals b to the x minus 2 if I wanted to. Okay? Here's where my other point comes in. My other point is over here at x equals 1, 2, 3, 4, y equals 0. So we have 0 plus 4 equals b to the 4 minus 2, which means 4 equals b squared. So we're asking ourselves, well, what squared gives me 4? That would be 2. Okay? And so we've got our equation. Y plus 4 equals either 1 times or just, oh, it's not b anymore. Sorry, we just solved for b. So either 1 times or just 2, because that's what b is, to the x minus 2. Okay? Go ahead and pause the video if you're going to. Give this one a shot. Okay, we have our y minus our y1 equals a times b to the x minus our x1. So hk, remember, is on the asymptote. So we're looking just below this coordinate point at our asymptote. That's my hk, which is at -3, and then y equals -1, 2, -1, 2, 3, 4, 5. We are at -3, -5. Okay. First coordinate point is out here at x equals -1, 2, 3, y equals -1, 2, 3, 4. So let's go ahead and plug that in. -4 plus 5 equals a times b to the -3 plus 3. -4 plus 5 equals 1. And we have a times b to the -3 plus 3 is 0. Anything to the 0 or b to the 0 is 1. And so my a is 1. Let's go ahead and rewrite this equation with that 1 plugged in. Y plus 5 equals 1 times b to the x plus 3. Now my other point comes in at x equals -1, y equals 0. 0 plus 5 equals, and we are looking at b to the -1 plus 3. Okay, so then 0 plus 5 is 5. We have b squared, and so we have to ask ourselves, well, what squared gives me 5? That would be √5. And so we have our equation. Y plus 5 equals either 1 times or just no 1, because again, what 1 times is. And we have √5 to the x plus 3. Okay. Okay, last up we have two, oops, sorry, let me put that last equation there. Last up we have two piecewise functions. Okay. So go ahead and pause the video, give this a shot. Okay, here we go. This first piecewise is made up of two functions. We've got a quadratic and we've got an absolute value. Okay, so let's go ahead and do the quadratic first here. Y minus my y1 equals m times x, the quantity of x minus my x1 squared. Remember, with a quadratic, it does matter what my hk is. My hk needs to be this vertex up here, which is at x equals -1, 2, 3, and y equals 1, 2, 3, 4, 5, 6. And so we have our 6 and our -3. Okay, and then we use our other point. You have several points to pick from. I am going to go ahead and pick this point here, which is at x equals -1, y equals 1, 2, 3, 4. So we have 4 minus 6 equals m times negative 1 plus 3 quantity squared. 4 minus 6 is negative 2, and negative 1 plus 3 is 2, squared is 4. And so my stretch is negative 1/2. So my equation is y minus 6 equals negative 1/2 times the quantity of x plus 3 squared. Okay? Now, really quickly, a reminder that when we are writing a piecewise, this minus 6 does need to come over to the other side. And so in preparation for my piecewise, I'm going to go ahead and add this 6 over now. Okay. Absolute value next. We have our, let's go ahead and let that focus. We have our y minus our y1 equals m times the absolute value of x minus our x1. Again, the HK does matter, the vertex does matter. We do need to use x equals 3, y equals negative 3. Okay. So plugging that in, negative 3 and 3. And then we're going to use another point. You can technically use either one. Let's go ahead and use this same negative 1, 4. Okay, so we have 4 plus 3 equals m times the absolute value of negative 1 minus 3. Okay, well, 4 plus 3 is 7. Negative 1 minus 3 is negative 4. The absolute value of that is 4. And so my slope is 7/4. So that's my equation. Y plus 3 equals 7/4 times the absolute value of x minus 3. And subtracting that 3 over, we have y equals 7/4, the absolute value of x minus 3, minus 3. Okay, go ahead and zoom out here for the final bit. Because now that we have our two equations, we just have to set up our piecewise. I'm running a little bit out of space, so I'm going to go ahead and turn to give myself room to write. Okay, so my first one is this quadratic, negative 1/2 times the quantity of x plus 3 squared plus 6. Okay. My second one is the absolute value, 7/4 times the absolute value of x minus 3 minus 3. And then we have to figure out, well, what are our intervals? So taking a look at this quadratic starts out here at x equals negative 7, and notice there's a hole. So for my quadratic, I'm going to go from negative 7 with a hole all the way over to negative 1. Okay, and I'm going to have that one be open because the absolute value starts again at negative 1, and I'm going to have that one be the point. Technically speaking, it doesn't matter. I could have this one be the point. I could put an equals here and have this one be the open. Doesn't matter. But I'm gonna put the negative 1 over here. Okay, and so my absolute value starts at negative 1, and it keeps going all the way over to x equals 1, 2, 3, 4, 5, 6, 7. And that one is a point at x equals 7, so we're going to have our less than or equal to. And so these are going to go side by side with their respective equation. Okay, so with my quadratic, we have our if negative 7 is less than x is less than negative 1. And our absolute value, we have if negative 1 is less than or equal to x is less than or equal to 7. And so there's my piecewise function. Okay. Okay, one more piecewise here. Go ahead and pause the video, give this one a shot, and restart it when you are ready. Okay, this one is a 3-piece piecewise function. So we have our horizontal line. We have either a descending line, if you prefer to think of it as linear, or part of an absolute value, if you prefer that. I'm going to treat it as a line. Okay, let's do our horizontal line first though, because that's pretty easy. Horizontal lines, what type of equation do they have? They are a y equals equation. And so in this case, this is a y equals 1, 2, 3, 4, 5, 6. So I always like starting there because it's friendly. Okay, then we have our linear. Again, you have a choice to make. You can make it linear, you can make it absolute value, but I'm going to make it linear. So we have our y minus our y1 equals our m times the quantity of x minus our x1. You can use any point as your starting point. I'm going to go ahead and use this guy over here, which is at 0, negative 1, 2, 3, 4. My y-intercept there. So we have negative 4 and we have 0. And then you need to use another point. So I'm going to use this guy at negative 2, 6. So go ahead and plug that in. 6 for my y plus 4 equals m times negative 2 for my x. 6 plus 4 is 10. And negative 2 minus 0 is negative 2. So dividing that over, my slope is negative 5. So my equation is y plus 4 equals negative 5 times the quantity of x minus 0, or just x. And then for the sake of my piecewise, I'm going to go ahead and subtract this 4 over. And when I subtract that 4 over, I'm going to go ahead and write this as just x. So we have negative 5x minus 4. Okay? And then last but not least, we have our quadratic. Y minus y1 equals m times the quantity of x minus x1 squared. Okay. My vertex, my HK here is at x equals 2, y equals negative 1, 2, 3, 4, 5, 6. Okay, so negative 6 for my y, 2 for my x. And then we need to use another point. You can use whatever point you want, but I'm going to go ahead and use this 0, negative 4. So we have negative 4 for y plus 6 equals m times 0 minus 2 quantity squared. Negative 4 plus 6 is 2. 0 minus 2 is negative 2. Squared is 4. And so my stretch is 1/2. We have y plus 6 equals 1/2 times the quantity of x minus 2 squared. And for the sake of our piecewise, let's go ahead and subtract that 6 over to the other side. Okay. And so then our piecewise, let's go ahead and put those in. We have our f of x equals, and then my 3 equations. We've got 6, we have negative 5x minus 4, and we have 1/2 times the quantity of x minus 2 squared minus 6. The only thing we still need to figure out are those intervals. Okay, so let's go ahead and come back over to our graph, take a look at our intervals. For the 6, we have an initial value out here that is a point, and this is at x equals negative 1, 2, 3, 4, 5, 6. So for my negative 6, we're going from negative 6, it is a point, so we have less than or equal to, over to negative 2, which is a whole, so we are not going to be equal to. Okay, my linear then picks up at negative 2. Which again was a whole, and goes to x equals 0. Now I have a choice to make. I can make that one a point for this guy or a whole. Let's go ahead and make this one the point, which means for my quadratic, that's going to be the whole, since the linear is already the point. And then my quadratic's going to start at 0, and it's going to go all the way to infinity. And so you have a choice to make here. You could technically put like less than infinity, or we could just leave it as x is greater than 0. Okay, so let's go ahead and put these into our piecewise function. We have negative 6 is less than or equal to x is less than negative 2. We have negative 2 is less than x is less than or equal to 0. And we have x is greater than 0, or 0 is less than x is less than infinity. Remember? Okay. And there you go. Good luck studying.